Hello, my name is Blessing. In this video I'm going to talk about base conversion of numbers in shell programming. So the very first question to solve is to convert a decimal number into binary, octal and hexadecimal number. Okay, so for that I'm going to first ask the user to insert a number that will be a decimal number, and then ask the user to select the option if they want to convert it into binary, octal or hexadecimal. Okay, if the user select the first, that is to convert it into binary, what I'm going to do is I'm going to run a while loop, and then this while loop will run till the number, the input will become is not equal to 0. Okay, now inside this while loop I'm going to do three expressions. The very first expression is to find the remainder of the number when it is divided by 2. So to find a binary number from a decimal number, we generally divide the number by 2 and take the remainder that we get in each step, and then combine this reminders as the binary number. Okay, so I'm first taking the remainder by dividing it by 2, that is a num modulus 2, and then I'm going to concatenate it to the variable called bin. So for concatenation we use $bin without any space between these two variables. Okay, then finally the third step, I'm going to remove the unit place completely and get the remaining numbers. For that I'm going to do is expr num divided by 2. So similarly the while loop will run till the number becomes 0, and then the bin variable will be echoed as a binary number. So now this was inside a case, so we are actually using a case to do that. So we end each case by 2 semicolons, and that's why I've given this 2 semicolons over here. And the second case is if this user selected an octal one, that is if they wanted to convert it into octal value. For that we again run a while loop, and inside the while loop we again take the remainder, but this time dividing it by 8 and taking the remainder. So the same logic over here, but just it is divided by 8, and then the remainder is concatenated with the variable called octet, and then again the unit place is removed by dividing the number by 8. And then finally the loop runs till it becomes 0, and as soon as it becomes 0, the remainder or the value stored in the variable is declared as the octal one. Okay, a third one is to convert it to hexadecimal. So here again the same logic, but this time it will be divided by 16 to get the remainder. So there are some changes in hexadecimal, because in hexadecimal we represent 10 as A, 11 as B, and 12, 13, 14, 15 as C, D, E, F respectively. Okay, so for converting into A, B, C, and so on, we're going to use a switch case over here. So we're going to check if the remainder is 10. If the remainder is 10, the case says that the remainder will be replaced by an A, and if the input is 11, it will be replaced by B, and so on with 12, 13, 14 and 15. And after it is converted into this following alphabets, it will check, it will remove the unit place of that particular number so that while loop can run, and I do it by using the expression expr num divided by 16, and the while loop will run till the number becomes 0, and after the while loop has run, it will display the value as hexadecimal value, which will be stored in the variable called hex. Okay, the second question is to, let me show the output of this question. You can see over here I have asked the user to enter a number, a decimal number, so they have entered a 10, and then I'm used to asked the user to give an input to select if they wanted to convert it to binary, octal or hexadecimal. So first they selected a binary value, so the binary value of 10 is 1010, and you can see over here this is octal value of 10, that is 1 to 12, and you can see over here the hexa value of 10 is the hexa value of 20. You can see I asked the user to give a decimal value, and they give us 20, and the hexa value of 20 is 14. Okay, second question is to convert binary into decimal, octal and hexadecimal. Okay, so again I'm using a case a switch case over here. So first one is to convert the binary into a decimal. So here what I'm going to do is I'm going to run a while loop, and the while loop will run when the input will become till the input will become 0, and then again I'm going to take the remainder over here. The expression is expr num divided modulus 10. So I'm going to take the modulus of the number which when it is divided by 10, and then I'm going to use another variable that is free, and here the expression is remainder is into power. So I'm going to into the remainder which I just got by dividing it by 10, and then into it with power. Initially the power's value will be 1, so initially the variable will have the same reminder in it, and then I'm going to calculate the decimal value by doing this. Decimal is equal to expr dec plus per. So I'm going to add this to number and store it as a decimal value, and then before the next loop starts, I'm going to increase the powers value by 2, by multiplying it by 2, and then I'm going to remove the unit place by doing the expression expr num divided by 10. So this will go on till the loop becomes 0, and finally I'm going to echo the value stored in the DEC variable as the decimal value. So that was the decimal value. Now if the user has selected to convert the binary into octal value, first what I'm going to do is I'm going to convert the whole thing into a decimal value and then convert the decimal value into octal value. So I told the procedure to convert into a decimal value in the previous previous question. So here I can say after it is converted into decimal value, what I'm going to do is I'm going to run a while, and this time again the decimal value it will run till it becomes 0. Inside the decimal value, inside the while loop, I'm going to divide the decimal value with a so that I can convert it to octal, and then concatenate the remainder into the variable oct, and then the loop will run. Okay, so finally I'm going to display the value inside the oct variable as my actual value. And similarly with hexadecimal, if for getting an hexadecimal, first you have to convert the binary into a decimal and then convert into a hexadecimal. So I'm using the same logic to convert the binary into decimal first, and then the decimal to hexadecimal. So in hexadecimal, I'm going to take the decimal value and modulus by 16, the remainder of the expression when is divided by 16, and then again in hexadecimal I'm going to check if 10, 11, 12, 13, 14 numbers come respectively. If it comes, I use a case to replace it by A, B, C, D respectively. And then finally I'm going to concatenate the remainder which I got by dividing it by 16 into the variable called hex, and this and so on, the while loop will run. And then finally I'm going to display the hex value in the hex variable as hexadecimal. Okay, so the input the output for this question is you can see over here I've asked to enter a binary number over here, so they have entered 1010, and then the decimal value is 10, and then again the binary value I've given 1010, and octal value is 24, and then again the binary value is 1010 and octal value is 8. So that was my third question. I'm moving on to the fourth question. The fourth one is to convert an hexadecimal value to binary, decimal and octal. Okay, so for that again I'm going to use a switch case, and this time if it is a binary, if the user wants to convert it to binary, I'm going to use I base and O base. It's a shortcut for converting bases. So I base is the input base and O base is the output base. So here the input base is 16 and the output base is 2. So using this thing I'm going to use directly calculate it and then print it. So that's why I'm given echo I base equals 16, O base is equal to 2, and $num and then modulus BC. So this E is going to be the output, and whatever output I'm whatever input I'm going to give it to the BC, and then the answer will be printed. Similarly for decimal value, the I base will be 16 and O base will be 10, and for octal value I base will be 16 and O base will be 8. Okay, so the output for this question is, you can see over here I've asked the user to give an hexadecimal value, and they give me 14. So the decimal value of that particular number is 14 again, and then the binary the octal value for 14 is 1012. Okay, so that's all with the video. Thank you so much for watching.